Okay, so in this video we're going to see how to find the mean, the standard deviation, and coefficient of variation for a couple of data sets. Okay, so let's start with the mean. And what I'll do is just kind of keep a running tally of all the statistics on this right side, so we can take them as we go on. Okay, so the first thing we need to do, let's again, we'll look at the city data first. And we know that the mean is going to be the sum of the data divided by the number of data points. Okay, that's the first thing we need to find. Now, the actual, the sum of the data, again, sigma x just means take the sum of everything. So we have sigma x equals 28 plus 40 plus all the way up to 24. If we add all these up, we get to 217. Kind of write that over here. Of course, we have 10 data points. We got to put the n over there. Okay. So now we can find the mean. So we'll go to the mean is going to be the sum of x, 217, divide by the number of data points, and so we get 21.7. Okay, so that is the average, what some people know as the average or the mean miles per gallon for the city data. Okay, so the next thing we need to do is find the standard deviation. So the standard deviation, again, we'll use the shortcut formula, the short version of the formula, which is, actually we'll find the variance first, because the standard deviation is simply the square root of the variance. So we have n times sigma x squared minus sigma x, the quantity squared, over n times n minus 1. And again, we have to differentiate between sigma x squared and sigma x quantity squared. So when we find the sigma x squared, that's going to be 25 squared plus 29 squared plus 25. So we're squaring all the data before adding them up. Because it goes all the way up to 16 squared. And so 625 and so on. And if we add this all up together, we'll get 4,907. And so we have the information, we have all the information we need. We have n, we have sigma x squared, we have sigma x itself, and of course n times n minus 1. So let's go through and find the variance and standard deviation. Okay, so s squared is going to equal 10 times the sum of squares. Now over here, this is sigma x, the whole thing, squared. That's the difference. Over n times n minus 1. Okay, so we have 10 times 4,907. And 217 squared is 47,089. Of course, 90. And if we plug all this information in, divide by 90, and we get 22.01. And so the standard deviation itself is going to be square root of 22.01. And we take that number and we get 4.69. Okay. Last thing we have to do is find the coefficient of variation. The coefficient of variation is going to be 100%, and we're going to take a ratio of the standard deviation over x bar. So we're taking the standard deviation relative to the mean, and so we have 100% times 4.69 out of 21.7. And multiply that by 100%, and we get 21.6%. So the mean is 21% of the standard deviation, which, seems somewhat sizable, but not huge. Okay, so that's how we find the information for our city data. Okay, so now we have to do the same thing for the highway data, and I will leave that to you to try on your own for a few minutes, pause the video, and then we'll come back. Okay, so let's see how you did. So for the sum of the data, and I'll just fill in some of these things here. The sum of the data, you should get 298. So 298 divided by 10, so that would be 29.8 miles per gallon for highway. If we add up all the x squareds, we should get 9,124. And so when we find the variance, let's see, we're going to get n times sigma x squared minus the 298 sigma x, the whole thing squared, again over 10 times 9. So we have 91,240 minus 298 squared. That whole thing over 90. And we get 27.07. And then the standard deviation itself will be the square root of that. And we get 5.20. .07. And then, of course, the coefficient of variation. Again, we have the mean of standard deviation of 5.20 over the mean, that's the 29.8, and that should come out to, multiply that by 100, 17.5. Okay, so the next thing is, assuming the distributions are normal, what data points would make up the middle 95%? Okay, so we're talking about outliers. Okay, so generally, the middle 95%, remember, that is assuming this is a normal distribution. Then 95%, this is part of the empirical rule, 95% of the data is within 2 standard deviations. So for the city, that's going to be 21.7 miles per gallon plus 2 times the standard deviation of 4.69, plus or minus. So it's going to be 21.7 plus or minus 2 times 4.69. That'll be 9.38. I'll round it to 9.4. And so we have our interval. 21.7 minus 9.4. 21.7 plus 9.4. So we would look at 95% of the data, if normally distributed, would be within that range, within that interval of values, and therefore less than 12.3, anything outside of that, or above 31.1, anything outside of that range, these would be considered our unusual values. And we'll do the same thing for the highway. Move this over a little bit. So for the highway, we have 29.8 plus or minus 2 times 5.20, 29.8 plus or minus 10.4. So our interval here is going to be 19.4 to 29.8 plus 10.4, which is going to be 40.2. And the same thing applies. 95% of the data, if normally distributed, will fall in this range, and the unusual values are less than 19.4 or above 40.2. Okay, the last question is with the Chebyshev's theorem. So Chebyshev's theorem, 75% of the data That's at a minimum, are within 2 standard deviations. Chebyshev's theorem does not require a normal distribution. It is a very conservative estimate. It's saying, within 2 standard deviations, there's no way you're going to have less than 75% of your data. I don't care how strange your distribution is. Well, okay, but we've already calculated plus or minus 2 standard deviations. That doesn't change. It's going to be the same 12.3 to 31.1 that we saw already. And for the highway data, again, it's going to be the same 19.4, 40.2. Okay, so we've looked at a lot here. We've looked at finding the mean, finding the standard deviation, comparing standard deviations, and also using that to find outliers, both from the normal distribution and using Chebyshev's theorem.